All right, let's start. Hello, everyone. As you know, this meeting is recorded and will be uploaded to public internet. So chances are whatever you say will remain there for a very, very long time. With that, let's start the meeting. I have a couple of items to talk about. Hopefully, these are not going to take much time. And then I know that there are a few folks who have some issues that they want to speak about. We may have actually a demo about Descheduler. Let me actually give you the quick updates. So one issue that we've actually Ravi had found was that the scheduler does not terminate in all scenarios when it loses leader lock. So when we run a scheduler in high availability mode or HA mode, the schedulers try to basically choose a leader among themselves by acquiring a leader lock. And once a leader loses the lock, a real action happens. Sometimes all the times when a scheduler loses this leader lock, it must restart. But apparently, in some of the cases that Ravi had tested, it didn't restart itself. He had sent a PR to fix this issue. Some other folks in the community believe that restart happens. So while the PR is fine and we can actually measure it, there is a question whether this is actually a bug fix or this is just a cleanup. The reason that it makes a difference is that if this is actually a bug fix, we need to backport it to older versions that we support, basically all the way to 1.13, I believe, that we support today. I don't know if Ravi is in a meeting now. I don't see him. Mike, do you know? Probably you don't know about the status of this change.
I don't know the status of this, but Ravi said that he's not going to be able to make it to this call.
Okay, all right. Yeah, so we can actually, I will follow up with Ravi later. Another update, quick update that I have is that we removed critical pod annotation a few weeks ago, but it caused some issues with static pods. We fixed that issue with some agreement from the SIG node. We decided to mark all the static pods or consider all the static pods as critical pods. And with that, we do not need static pods to actually have a priority or have any annotation or anything to be considered as critical. All of them are considered critical, no matter what their priority is or whether they have an annotation or not. So after that fix is merged, we now have been able to remerge the removal of critical pod annotation, and that has happened yesterday. These are the two updates that I had. So let's see. I believe Swati, you have some, I don't know if she's on the call. She has a demo for us, I believe, but I don't know if she's here. All right, in the meantime, is there any question or comments or updates from other folks in the meeting?
I have one small thing. I don't know if this is the right place to bring it up. We had a test that was flaking around pod taints and tolerations that Ravi tried to merge a fix, which broke the test, so we reverted that fix. I've got another PR that I just opened today, which basically brings in Ravi's fix and tries to complete it so that it shouldn't break at this point. I should just put a link to that in the doc.
Yeah, please do. If you can, please add it to the meeting notes. And another question that I have for you guys is that Ravi reached out to me and said that you guys plan to rewrite some of the preemption tests because they're flaking in your environment in certain scenarios. I actually don't know. Do you plan to convert them into integration tests, or you plan to just rewrite them in a more reliable way as end-to-end tests?
From what it sounds like, talking to Ravi, we'd like to move as many as we can just to integration, because we have on OpenShift we have a lot of really high load tests. We've got a bunch of other end-to-end tests running in the background with all of our operators and stuff. I think that our goal is to move as many of them as we can to integration, and then rewrite others where we can't move them.
Yeah, we definitely need to have at least one, probably more than one, end-to-end preemption test, because we want to make sure that preemption actually works, so we can definitely delete pods and we can update API server and everything. So we definitely want to have an end-to-end test for preemption, but generally I am okay with converting end-to-end tests to integration tests if we don't lose any functionality of the test.
Yeah, we did talk about leaving a couple that I think you had pointed out, at least as critically end-to-end that we don't want to move over. So it's not like we want to move everything over. So I think that sounds good.
All right, sounds good. All right. Any other question, comment?
Yeah, Bobby, I was looking for review. I pinged Klaus, but I haven't got any response on that.
Sorry, you said you didn't get a response?
From Klaus, yeah. I was looking for a review. Like, there's only one change which is pending. So it's been like a long time and only one comment which is pending. And it addresses functions outside the PR as well. So I was looking for some input on that.
I see. So yes, I actually, I also chatted on chat. I told you that I'm not fully aware of that change. So I would rather someone who has reviewed it so far. I know Abdullah is on vacation, but he's coming back, so he can probably provide a response for those early next week. I hope that's fine with you, because we still have some time before the code freeze, right? So code freeze is at the end of the month. So we still have some time. Hopefully we can merge it before that. And I mean, not hopefully, we should definitely merge it before that.
Yeah, I think next week sounds fine, for sure.
Yeah, and I can actually ping Klaus as well.
Yeah, cool.
So Swat is now in the meeting. Swati, do you have a demo for us?
Sure. Can you hear me okay?
Yes.
Okay. Yeah, so just give me a couple of seconds. Trying to share my screen.
Right.
Yeah. So let me know when you can see the screen.
Yes, we can.
Okay. Oh, it seems to have taken the other route. Okay. I'm not sure which screen are you seeing.
I'm seeing a slide, propose the strategy in Gscheduler, remove pods violating node taints.
All right. Okay. So the whole idea is that we're proposing a new strategy in the descheduler project itself, and this was one of the strategies that were being that were mentioned in the roadmap of the descheduler project. And the idea is that we look at the no schedule taints and tolerations and see if those taints and tolerations are compatible after a pod has already been scheduled. And the scenario here is that what happens in case the node taint is updated after a pod is already placed. So in the slide now you'll see, so we have a pod which is scheduled on the node for the first node, and it has a taint which correspond. It has a toleration which corresponds to the taint on the node. However, in a scenario that taint gets updated on a node, the pod, this particular pod is violating its placement intention, so it needs to be rescheduled. So that's essentially the idea behind this the strategy that we're proposing. Can you see the shell here?
Yes.
Okay, so I'll show you the nodes. I have a 2-node cluster over here, and what I'm going to show you is that I'll deploy a deployment with 10 nodes, and they'll be distributed across both the nodes. And once we taint a specific node, those pods should be moved off to the other node, because the corresponding pods would not be compatible with the toleration that has been specified. So let me just show you the deployment that I'll be scheduling. Yeah, so deployment pod taint. So here it's a simple deployment, Nginx pods, 10 replicas with a toleration key and value. And the important thing that that I need to mention here is that this is for no schedule taints and tolerations. So these are the pods. Let me just quickly show you that. So this is a small script that shows the taints on both the nodes. At the moment, we have no taints on the node, and when I deploy the deployment, just pick it up from here. When I deploy the deployment, get pods. So you see these deployments are being scheduled on both the nodes. So we have 419 and 877 nodes. The scheduler tries to distribute its deployment across multiple nodes. So that's what it's essentially doing. And what I'll show you here is that if I assign a taint to the node, so taint node, okay, slash taint node. So I'm tainting this node with a key and a different value, say val2. So, dot slash show. So my master node, this is the master node, and it has a taint being assigned, which violates the toleration of the deployed pods. So the pods continue to keep running here. So the pods are continuously running. So I'll just go to the descheduler shell, and so exec. Okay, I'll just dot slash bin descheduler -h. So I'll pick up the policy configuration file. Where's the policy? Yeah, so this is the policy file. Okay, there you go. Okay. Sorry. So in this case, there are a bunch of pods being deleted. So if you go back to the previous shell, you're seeing that a few of the pods are getting terminated. Subsequently, a few pods are getting recreated. And at the end of this descheduling process, all the pods are on the other node, which is no longer tainted. So this is the strategy that we are proposing. And it also shows that the descheduler, which is running in the kube system namespace, continues to run, even though it was on the master node, because it's a special pod. So that kind of summarizes the demo. We have a PR up on the descheduler repo. Avesh is supposed to review it, but if we can get more feedback on that, that would be great.
Sounds good. Thank you very much. One quick feedback that I have so far is that looks like no schedule taint causes a node to drain, basically, with your change.
Right.
If someone wanted to achieve this, they could have used no execute taint, right? Which would have the same effect. If they really wanted to drain a node, I think they would probably put a no execute taint on a node. Probably this is going to be something unexpected to happen, I would say. Probably someone puts a no schedule taint on a node because they don't want the existing pods to terminate on the node.
Yeah, so yeah, I think you're right in that sense that if they'd want this behavior, they'd use a no execute taint. But the problem that we had was in a deployment that is up and running, and you have a no schedule. If you want to clean up your environment and you want to make sure that your running pods are consistent with the cluster that you have, you'd probably run this as a cleanup operation to ensure that everything is compatible and in a desired state. So that was the whole idea. And I think there was, so this issue already existed in the descheduler repo, and there were people who wanted this feature. So that's where it kind of started.
I see. Yeah, I can see that, you know, in certain scenarios this might be useful, but I think it could. So this definitely should be configurable because it could potentially cause surprises as well. Because, you know, people may think that, oh, if I just put a node schedule, the node is not going to get new pods, but suddenly they could see, oh, even the existing pods disappeared, which is not exactly what the API says.
Sure.
So yeah.
Yeah, so this is again, it's a strategy that is configurable in the descheduler config itself. So only if you want this behavior, you can include it in your configuration and you'd get this behavior.
Yeah, sounds good. Thank you very much.
Thanks, Bobby. Let's stop sharing my screen.
Yeah,
So hold on. So I still didn't get that. So you just said the main reason is that you still want your, for example, your workload YAMLs to be compatible as what it was before, right? So that's the main reason.
Right. Yeah. So like at the time it was being scheduled, it was complying with the taints that were on the node. Like the tolerations that the pod had was complying with the taints existing on the node. But in a certain scenario, the taints are updated or your cluster gets updated. That compatibility is no longer correct. So it's not complying with your provided tolerations. So that's the whole idea.
yeah, basically, the way, you know, one of the reasons that we were thinking about having a descheduler is that the scheduler tries to bring the cluster at runtime to a state that is specified by the API. For example, if a node has no schedule, no pods is scheduled on the nodes, or if you know, we have other scenarios here. For example, anti-affinity could get violated, so it could bring the cluster to a state that is compatible with the specified API and so on. This is kind of aligned with the same promise of the scheduler. So if we have a no schedule taint on a node, then we want to basically ensure that at runtime we are adhering to that desire, basically. And that's the idea.
I know this scheduler, the purpose of this scheduler, but I think no matter what the add-on of additional feature is added to this scheduler, the principle is it still needs to align with the API, right? And for this example, actually, it disobey the API, in my opinion, actually.
Okay, can you explain that a bit? Because
no scheduler just means, okay, the pass on the nodes, then we don't touch that, no matter what kind of taint is added later on that node, right? That is the semantics of the API.
Yeah, I think, yeah, yeah, what you're saying is correct in a way that, so the pod, where the pod is scheduled is only considered when that request comes initially. But the descheduler project itself talks about scenarios where you would want to actually change the placement of the pod to achieve a desired state in your cluster. So descheduler project kind of talks about like scenarios like violating the pod anti-affinity policies, having pod anti-affinity or node anti-affinity policies. So things like that are considered in descheduler. So what we are doing is proposing another strategy where the taints are no longer compatible with the tolerations that the pods have.
Yeah, since we have an alternative kind of taint, I kind of agree with the way that this could be a surprise for users, especially if they know about both of these two taints and they purposefully put a no schedule taint in order to save existing pods on a node. Then some feature like this could cause surprises for users. So what I would suggest is that if you can add this strategy to the scheduler, but keep it disabled by default, so only users that really want this feature can enable it.
Sure. Yeah, that's not an issue at all.
Yeah, I will leave this question to Ravi, yeah, to see how he responds.
Yeah, so I think I mentioned, I pointed Ravi to the PR, and Avesh is the reviewer as well. So if I get some feedback, I'll take that into consideration. But this is a good point that we will have it under a feature gate or kind of hidden by default unless users want to actually enable it explicitly.
All right. Yeah. Thank you.
But I have a couple of questions. Is the scheduler supposed to be run on command, or is it supposed to run continuously?
Yeah, so the project itself, it proposes and it says that it should be run as a cron job to clean up your cluster. In this case, I explicitly run the command to just show you the logs and the pods that are being evicted.
So one thought I have is that it might be useful for this kind of behavior, because it violates the API. It might be useful to have it as an audit system that will tell the operator these pods are in violation, but it wouldn't actually evict them.
Okay.
Just because the API doesn't say so. I don't know if it's outside of the goals of the scheduler, but just to be compliant with the API, that sounds to me like a better idea. Or on the other hand, if I'm as an operator want to at one point clean up my cluster, then I run just this one time, and then I'm happy with the results.
Yeah, so far, like the use of descheduler I've seen, this has been used as exactly the way you just described, as a cleanup operation once in a while and not as a cron job. But in the repo itself, like it said that you'd run it as a cron job, like maybe running once a day or something like that as a cleanup operation. But yeah, I've seen it being run once in a while, like whenever you need to achieve a desired state.
Yeah. Sounds good.
Okay. Hi, this is Jed Record. I was just wondering if you could share a use case that might explain why someone would want to automate or put this into a cron job for these descheduling activities, because I'm unclear how you would have changes in the taints and the pods already running without how you would have that coming up so often that you'd want to run a cron job to remove those workloads.
So like I mentioned, so this was an issue that was already existing in the descheduler repo itself. So I kind of picked it up from there, and kind of it was an attempt for me to get an understanding of how the descheduler works, and so I thought, okay, this is a problem that exists in the repo, and I'll go ahead and try to solve it and get an understanding and understand the architecture of descheduler itself. So that's where it came from. I don't have a specific use case itself, but the issue described it exactly the way I did. that I can link the issue as well in the agenda item as well to describe it well. But the idea was that in scenarios where your taints on the node get updated, you'd want to ensure that
I
your
think
pods are
Jeff's
compliant.
yeah, I think Jeff's question is more generic, I would say. Jed, are you asking why do we ever need to have descheduler for any reason or for this particular feature that we talked about?
No, I think she was addressing my question. I just wanted to make sure that when we're submitting these types of changes that we know exactly, or we have some examples of users who actually have this need, right? So if we're just coding to respond to gaps that we see in the API or something to that effect, that to me doesn't seem very valuable unless we're making contributions that are in response to the needs that users are actually having.
Yeah, I mean, some of these changes are useful, particularly because our own scheduler does not really check anything for running pods, right? So it only cares about pending pods, which are not scheduled yet. So if cluster conditions change at runtime, of course, the scheduler will no longer care. The scheduler helps with bringing the cluster to the desired state. And so,
yeah, I understand, and I think it's a valuable process. But like one of the other people here who mentioned the fact that running it on a cron job is different than having an admin executing it on a as needed basis. It scares me that somebody might set this up not knowing what types of jobs would be descheduled.
yeah, no, I understand. Although once it becomes like a established feature of the cluster, people will probably think about it and care about it. For a matter, I mean, if it matters, we also have something similar on Google. Borg has something like Descheduler as well that checks the cluster and tries to bring the cluster up to the standard state or the configured state. It's not something completely uncommon in cluster management.
Well, and with the nature of what we discussed, that it may stray from the API, I'll flip my opinion here a little bit and say, it certainly is the nature of declarative infrastructure that we want to maintain the state that the cluster has been asked to perform. So I would agree with that. It's just the running this in an automated way made me a little nervous without truly understanding what the need was for that. But certainly I like to have a cluster maintain a state that I anticipated it operating in. So I guess I'm flip-flopping a little bit.
I agree with you. This definitely could cause surprises if you're not fully aware of what it exactly does.
If you allow me to follow up on Jed's comment about the use case, I think it will be useful to know which use case is this serving that is not served by not execute. Because there is that option already.
Yeah, that was my question as well.
Sure.
So, yeah, this is actually something that could probably cause surprises if user is not fully aware. But as we discussed, a user can probably, we can leave it as disabled by default in Descheduler, and users who really want to have this kind of behavior and checks at runtime for no schedule taints as well, then they can enable it. But otherwise, you're right. I don't think it achieves much more than what a no execute taint can achieve.
Yeah, I'll try to follow up on that specific use case itself, like to identify what application or what use case would benefit from a scenario like this, just to add more details in the PR itself. So it just helps everyone.
Yeah. Sounds good. All right.
Cool. Thanks for your feedback, everyone.
Thank you very much. And we are officially out of time. Is there any quick question or comments? All right, let's end the meeting then. Thank you very much, everybody, for attending. I'll see you guys next week. Bye.